I'm going to talk about developing the rigid box structure in the 3D program. So for my sketches that I had shown in the last class, this is the sketch I'm deciding to develop. Again, it's for the watch, so it would be a high-end watch product, and this is going to be the rigid package for that. All right, let me switch over to the 3D program. Okay, so I have all this set up on layers. I'm just going to go through the process of developing this. So this will be quite different than the folding carton and the corrugated project. Rigid box structures are made in a very different fashion. It's more of a handmade kind of assembly. It's not like creating a die line and then folding that up and creating the carton. These are essentially handmade. So each part is built and it's fabricated and put together. Sometimes die line processes will be used by the vendor to create some of the parts, but as a designer, we're going to build this by hand to make mock-ups to simulate the structure and the functionality if we were trying to accomplish. So like the other projects, we have to start by building our product. So I'm using a watch. So I had a watch that I'm imitating that I wear. So I'm just building the watch geometry, kind of rough. It's not all the complete details. All I'm doing is making sure I have the right size. So here's the diameter of the face, the thickness of the bezel, and then allowing some space for the band. But you can see it's modified. It's very simplified. I don't have all the details. I don't have the buckle. I don't have the turn knob. But all this geometry here will simulate the actual watch. So in doing this, I'm starting off by following the lead of other watch boxes and how they work. Quite often, if you have bought a watch, they wrap the watch around this kind of oval padded insert that goes inside the box. So I'm starting with that, and I'm measuring one that it had existed. So in doing that, I simply just go to some of these objects. So for the product, all I have is this oval solid. And then I put the bezel on top. So that represents that geometry. And then from there, I could make that center pad. And again, I'm measuring this and making sure I have enough clearance on both sides. And then this simulates what already exists. So after that, the next step was to start to build the other parts. Go to my layers. So this design, I was putting this component inside of this tube shape. So this is done just by the 3D wall tool. I'm not going to go through every fabrication because a lot of this is pretty straightforward. Those oval components that I made are just made from the oval tool and then extrude them into the thickness that I needed. Here, would use the 2D wall tool, which is right over here. And you can control the wall thickness. I'll just demonstrate. See, let's do 1/8 inch. And I'm having bottom open and closed. We can make those closed if we want. So we can select these things and then provide a thickness for that. And then the height, I'm just going to do 2 inches, kind of random. So if we look at it from the top, and let's say I use the round tool, I can, I got to draw on 2D wall. Here we go. So you can see the 2D wall comes up right away. So I pick my diameter. I can do it from the inside diameter or the outside diameter by selecting justification left or right. And that did it as two-dimensional. I didn't have it set on 3D. Let's do that. And there it is. So it's pretty simple geometry, and it gives me that size. So after you build it, you can then scale it up and down to make it fit to the size. I have this scaled, and you'll see what justified how big those were going to be. Okay, let's just get rid of that. So you can see I'm working from the inside out, very similar to our other projects. Product first, and then start to build out and work with what we know from there on out. So the next part is Okay, I did show the disc. Here, let me, goes this. So I have that around there. So from the top of that circle, the inside diameter, I created this little disc here. Now this disc is what's going to support the oval inside of that round tube. So I just made that fit in there and then cut off the ends because that's what the clearance is for the strap. So I'm going to develop all this 3D geometry and then use that as a guide. It'll be more like a shop drawing. If anybody has taken wood shop and they built like a birdhouse or a step stool, you're not developing a die line, but you're developing an assembled drawing of the part and what it looks like. And you're looking at it orthographically and you're deriving all the, let's say, the cutouts and the notches and things that you need to do to fabricate that part. This is the same process that we're going to use here for this workflow. So I knew I wanted from my sketch, I wanted the top of this box or the proportions of this box to be square. So I just decided to make a square shape, this proportion, which gives me enough clearance around the parts so I can have that circle in there. I'm going to build a filler in here that's going to support that. And I can look at my dimensions. So, a little over 4 inches by 4 inches, which is a nice size. It's pretty compact. That's actually part of the stipulations of this project. I'm making this up just for our class, but it is based on a real project that I was working on. So let's unghost the tube. So that's sitting inside there. So then again, I need another, I'm calling these fillers. So I have this square box. It will have a floor, but I want to support this tube in the middle of that square box. So if I were to ghost the box part, you can see I have another panel floating up here at the top. And all I had to do is difference this tube from that panel to create that hole. So that's the whole base of this box. So the one part and the more intricate part is this cover component. So from the sketch, you could see I had these four triangular sections that form the square that fit over the top of the box and make the closure. So this was a little bit more challenging to figure that out. So I wanted these four pieces to be the exact same height as the base. So when they're open, everything lays out flat on the deck or the surface that you're opening this on. So that was a given. So I had to adjust the heights of these parts to get that to work. And another part of this, the feature of this part, is that I want it to come over the top of the watch and not lay its weight. So any pressure on the top of this box would not be pressing on the watch. I want it to be pressing on the tube. And that's the height of that tube is significant because that's what's keeping those upright in that position. And also, these are going to be hinging off of that bottom box. So when all four of those hinge at the same time and they meet in the middle, that is also supporting all that weight. So I had this triangulation on all four sections, they're all leaning against themselves and they're pressing on that inner tube. So we have a lot of support and structure on this. Part of this was to create a portable box that someone might put this back in. It's a relatively expensive product, and a lot of the collectors like to put them back in their box, keep them clean, keep them in a storage component that they would reuse. So once that's set up, these are the parts that I need to make. The triangle just gets multiplied four times, and then I can assemble that. So I'm going to show how to fabricate that. But what we need to do is, for our own projects, we need to take all of this geometry that we have built, and we need to set it up as a layout. Like I was saying, I'm calling it like a shop drawing. It's something that you're going to work with to build all these pieces. And it will be a bit of a guide, but you kind of want to go through this process to see how all these parts are going to fit. So you can see right down here in the bottom is where we're starting from. So all I'm doing is taking all of that, all those components, and I'm just turning it sideways and putting it above that to create these orthographic projections. So this time, I am not creating a die line. Like I had mentioned for the folding carton and the corrugated, we built the 3D object and then we derived a die line from that. So that's actually a little bit more difficult because we have to figure out how all those components are going to work in as a die and as a 3D file and work. Here, we're just building this. We're just going to build this by hand. We're going to cut out these pieces and glue them together and assemble this. And this is what we're going to use to guide a vendor who makes case-bound boxes. And they will use this as a guide. And they will make some decisions about what they want to die cut, how they want to trim pieces out, and how they want it to glue it together. Because eventually this will be wrapped with an overwrap. It could be a fabric, it could be leather or various different materials that are pre-printed or embossed and die cut. So we are just going through the design process of what we want, functionality and aesthetics, and then we'll work out the details. If someone wants to hand wrap their structure after they build it, that's perfectly fine. It's just a little bit more work, and we don't necessarily need to go through that as a designer. We can work with vendors, which I do quite often when I'm doing rigid boxes. I'll work with the vendor, and then they will make determinations about certain details and how it's set up. So I'm not going to dictate to the vendor which part he die cuts. That'll be their decision. So we take all our pieces. Here you can see I took the 4 triangles and I'm showing in its open position from the front and the top view, and I have the little watch, the oval watch pad set up there so I can see how big that is. So these are the parts, and I set up a border, which is not fitting. Let me set my zoom fit. Let's put that at 0. And it will fit. In this case, you could leave the grid on. It could be a guide for you to make your parts. I'm just going to leave that off. So let's put this on here so it's a little tighter. Okay, this is in shaded interactive mode. So now I can take this, print this out full size. I could print these little parts separately. It doesn't have to be one page because this is just a working drawing for me to fabricate a mock-up of this design. But now I can go in here and I can measure all these right off the paper if I print them full size and fabricate these parts. I had selected a wall thickness. I think it's about 100 thousandths, which is slightly less than 1/8 of an inch. It's some black board that I had, so I'm going to fabricate this out of black board because ultimately this will have a very dark blackish kind of woven material on it. So I wanted to simulate what that's going to look like. And I'm going to show also how to create tubes and these oval shapes by doing a bent lamination process. Okay, so this is ready to be printed and fabricated. So in the next tutorial, I will show how this box is assembled and made.